Now we're on our third chapter, which focuses on number theory. We're going to first address factors and multiples. Then we're going to go into divisibility. Let's first talk about what a factor is. A factor is a whole number that divides the given number evenly. Okay, let's see what we mean by that. List all the factors of 10 in numerical order. So we want to find a number, a whole number, not a decimal or a fraction, but a whole number that divides evenly, okay, without any decimals, divides evenly into 10, into this given number. So what numbers are able to divide or go into 10? Okay, so we know 10 times 1 equals 10, so I can divide it by 1. And then what other numbers go into 10? Okay, 2 times 5 can go into 10. No other numbers can go into 10 evenly. So let's take a look at this. Okay, we said 1 times 10 equals 10, and then 2 times 5 equals 10. Those are the only numbers that will divide itself into 10 evenly. So this is specifically asking, listing those factors, listing those numbers, and we'll go least to greatest. So 1, 2, 5, and 10 will go into 10 evenly. That's our answer. Those are the factors of 10, whatever can divide or go into 10 evenly. Okay, let's try this again. Practice number 2. Find all the factors of 30 in numerical order. Okay, find the numbers that are whole numbers that go into 30. Well, we know 1 times 30 equals 30, so we have 130. What other numbers can go into 30? Since we started with 1, let's focus on 2 now. Okay, we said 1 times 30 equals 30. Let's focus on 2. Can 2 times something equal 30? Yes, 2 times 15. Okay, good. What about, let's move on to the next one, 3. Yes, 3 times 10. What about 4? We'd have to do some math, do a little thinking about that, and no. Okay, not 4. What about 5? Yes, 5 times 6. Oh, 5 and 6 are numbers right next to each other. There would be no number between them, so those would probably be all our numbers. 1, 2, 3, 5, and then we're moving on the other side, so 5 times 6, so 6, and then 10, 3 times 10, and then 2 was 2 times 15, so 6, 10, 15, and then 30. So if we look at the left side, 1, 2, 3, 5, and then let's go on the right side, 6, 10, 15, 30. Those are the only factors. Okay, here's another example. List all the factors of 25. Okay, I want you to go ahead and pause this and then see if you can do this on your own. Use some of the previous examples to help you. Okay, if you went ahead and unpaused this, let's see what we did. We know 1 times 25. What else can go into 25? Well, we know 5 times 5 can go into 25. Okay. Can anything else go into 25? Well, we already see 5 and 5 is an equal number there, so most likely no. Okay, so 1, 5. I don't have to repeat 5 twice. I can just say 1, 5, and then 25. Now let's do something a little different. Looking at these two numbers, 3 and 18, let's look at the question. The question is asking, is the first number, the 3, a factor of the second number? Does 3 go into 18? So we can think through, is there 3 times something equal 18, or can 3 be divided into 18? So if we have that, okay, we know that 3 times 6 is 18, so the answer to this question is either yes or no. 3 times 6 is 18, yes. Okay, here's another example of this. Can 12 go into 42? Well, we can easily divide and figure that out. And by doing that, we can actually see that no, 12 cannot go into 42. 12, the closest, 12 times 3 is 36, and then 12 times 4 is 48, so it would not be a factor. Okay, then let's look at practice number 6. Can 4 go into 132? 4 times 33 is 132, so the correct answer would be yes. Okay, so that is the focus on factors. So go back and watch this if you're still a little confused. Please also go ahead and do the not only the Fitbin, but do the practice textbook work, please. Now let's focus on multiples. The definition of a multiple is any product, so product is dealing with multiplication, of that number. So we're multiplying that number that we're being addressed with that is not a fraction or a decimal. So let's see what it's talking about. Okay, so it's a product of the number. That's why we're calling it multiple. So they want me to give the first 6 multiples of 5. Now, 0 is a multiple of every number. So if you were asked give the first 6 multiples, you would include 0. But most commonly, textbook or a worksheet or someone may ask you to give the first 6 non-zero multiples. So that would not include 0. But if you are asked for the first 6, it would be 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25. Now, if you're asked for the first 6 non-zero multiples, we're not going to do the 0 times 5. You would just do 5, 10, 15, 20, 25, and then you would do 5 times 6, which would be 30. So remember, a multiple is the number. Remember, a multiple of a number is a product. Product means we're multiplying that number times the next available numbers. That number, which is 5, times the first 6 numbers. So 0, 1, 2, 3, 4, 5. Okay, let's try practice number 2. Here in this example, or this practice, it says non-zero multiples. So we're not going to do 0 times the number, but we're just going to do the first 4 non-zeros. So we're going to start with 1. It's asking for the multiples of 2. So 2 times 1, 2 times 2, 2 times 3, and 2 times 4. So 2 times 1, 2 times 2, 2 times 3, and 2 times 4. And the multiples deal with the product, the answer of the multiplication. Now remember, a factor goes into the number, while a multiple is multiplying that number by 0, 1, 2, 3, 4, 5, 6, 7. Okay, let's try another example, another practice. This asks for the first 6 multiples of 10. So I'm multiplying the numbers by 10. Now it doesn't say non-zero, so let's first start with 0. 0 times 10, 1 times 10, 2 times 10, 3 times 10, 4 times 10, 5 times 10. Okay, those are our multiples of 10, our first 6 multiples. Now remember, if it is asking for the first 6 non-zero, we would start with 10 times 1 and then go till 10 times 6. Okay, let's try another practice. What are the first 6 non-zeros? Non-zeros, multiples of 6. So we'll first start with 6 times 1, and then we would go all the way to 6 times 6. Those are our 6 non-zero multiples of 6. Okay, now let's focus on divisibility. When we say divisibility, we first think of dividing. Okay, can we divide into something? Divisibility is the ability of a number to be divided by a certain number. That gives you a whole number. So we will not be yielding a decimal. Okay, so there are rules that I'm going to give you. I'm going to actually give you a total of 8 to 9 different rules. Divisibility by 2. This is going to be focusing on a certain rule that we want to follow. Maybe you want to make index cards for these divisibility rules. This will help you remember the basic gist or definition or rule for each of the divisibilities. Divisibility by 2. A number is divisible by 2 if the ones digit is even and if the last digit is divisible by 2. Okay? So if the ones digit is going to be even, so if it's 2, 4, 6, 8, 10, and that last digit can be divided by 2. Okay? Let's focus on the rule for divisibility by 5. A number is divisible by 5 if the digits, the ones digit, the ones place is 0 or 5. So if I have, what about 10? Is 10 divisible by 5? Yes, because it's going to end with a 0. 5 times 2 is 10. Okay, so if the ones place is a 0, so 5, 10, 20, 30, 40. 5, 10, 15, 20, 25, 30, 35, 40. And then divisible by 10. The rule here is a number is divisible by 10 if the ones digit, ones place is a 0, such as 10, 20, 30, 40, 50, 60, 70, 80, 100, 110. If it ends with a 0, it would be divisible by 10. Okay, let's look at some practice examples. Okay, so we have 4 examples: A, which is 12, B, which is 40, C is 75, and D is 88. Okay, which numbers are divisible by 2, 5, and 10? Let's first focus on 2. Let's go through all these. Okay, 2. Can 2 go into 12? Okay, is 12 divisible by 2? Okay, let's see if that's going to work. Okay, let's look at the rule. Okay, the ones place is even. So yes, 2 goes into 12 6 times. Okay, let's see if letter B can go into 2. It is even. And the last digit, the 4, is divisible by 2. So yes, 2 can go into 40 20 times. Okay, letter C. Can 2 go into 75? The ones place is not even, so no, it would not be able to go into 75. And then the last one, D, can 2 go into 88? Well, using common sense, 2 times 44 is 88. But using the rule, yes, it can, because 88, or the 8, is even. Okay, let's try, can 5 go into these? So we found that 2 can go into A, B, and D. Let's see what 5 can go into. Remember, the number can only be divisible by 5 if the ones place is 0 or 5. A is 12, not a 0 or 5, so 5 is not divisible, or 12 is not divisible by 5. Let's try B, 40. Okay, the ones place is a 0, so it is divisible by 5. So we have 8 times 5 equals 40. Okay, C. Okay, the ones place is a 5, so 5 can go into 75, yes. And then 88, D. Okay, it's not a 0, it's not a 5, so the 5 cannot go into 88. So 5 can be divided into B, 40, and C, 75. Okay, let's try the last number, 10. Can 10 go into 12? No, the last digit is not a 0. Can 10 go into B, 40? Yes, the last digit is a 0. And then we look at C and D. Those are not zeros, so 10 can only go into letter B. So, what numbers are divisible by 2? 12, 40, and 88. What numbers are divisible by 5? 40 and 75. And what numbers are divisible by 10? Only B, 40. Okay, let's take a look at the rules, the next three rules, divisibility by 3. A number is divisible by 3 if the sum, this is pretty interesting, the sum, this is talking about adding, the sum of the digits is divisible by 3. So this is pretty interesting. Let's jump down to the practice, letter A, 120. Okay, you know what we can do? We can make this real easy. We can look at the sum of the digits. 1 plus 2 plus 0 is 3. 1 plus 2 is 3, plus 0 is 3. Is 3 divisible by 3? Yes. So we very quickly just counted up the digits. 1 plus 2 plus 0 equals 3. Can that sum, for the divisibility rule by 3, can that sum be divisible, okay, by 3? And we figured out, yes, 3 into 3 is 3. Okay, now if we do some long division, I can pretty much do that in my head with 3 times 40 is 120. But look at these other numbers. Look at letter B, C, and D. That's going to be a lot of work, okay, to go ahead and do all that dividing. But if I add these numbers, I may be able to come up with some answers a lot quicker than I would if I was just dividing. Now let's look at the divisibility by 6. A number is divisible by 6 if the number is divisible by 2 and 3. Okay, both 2 and 3. Is 120 divisible by 2? Yes. Is 120 divisible by 3? Yes. Well, let's go back to the 2. 2 times 6 is 12, so 2 times 60 is 120. Is it divisible by 3? 3 times 4 is 12, so 3 times 40 is 120. So we can identify that letter A, yes, is divisible by both 3 and 6. Now let's focus on the rule for divisibility by 9. A number is divisible by 9 if the sum, we're adding these numbers again, the sum of the digits is divisible by 9. So 1 plus 2 plus 0 equals 3. Is it divisible by 9? No, it's too small. Okay, but let's go ahead and do letter B. 2 plus 7 is 9, plus 14 is 13, plus 5 is 18, plus 4 is 22, plus 8 is 30. Now, that number is 30, and we can go ahead and see, does 9 go into 30? No, it doesn't. But let's go back to the 3. We did the sum for this as well, and we figure out 30. 274,548, the sum of those digits is 30. So 3 can actually go into that. We know 3 times 10 is 30. So we very quickly were able to count them, figure out if 3 went into it. 9, however, will not. But let's go ahead and I'm going to give you some time, pause it. I want you to see, can 3, 6, and 9 go into letter B, C, and D? And then you can go ahead and unpause this and check your answers. Please follow the rules. Okay, so 120 is divisible by 3 and 6. We went over that one. 274,548 is divisible by 3 and 6 because if I add up those numbers, it's going to give me 30 to help me figure out divisibility by 3, but not by 9. And then can 2 go into 30? Yes, 2 times 15. And then can 3 go into 30? Yes, 3 times 10. Okay, that's for the divisibility of 6. Let's look at letter C. 17,505,439. If I add up those numbers, that gives me 39. So none of those numbers, 3, 6, and 9, will go into 34. Now let's try 26,307. Okay, if I add up those numbers, it gives me 18. So 3 and 9 can go into 18, but I'm not going to do the sum for 6. 6, I'm going to see, can 2 times a number go into 18? Yes, 2 times 9. And then can 3 go into 18? Yes, 3 times 6. So if you can remember divisibility of 3 and divisibility of 9, you're going to be coming up with the sum. You're adding those digits together to figure out a sum to see can 3 and 9 go into that sum. 6, however, you're seeing can the number be divisible by 2 and 3. Okay, we have 2 more rules. And you can see here there are 3. There's divisibility by 2, but we've already talked about that, so we're going to kind of just jump over that and then focus on 4 and 8. This is a number divisible by 4 only if its last 2 digits form a number divisible by 4. So here are some examples. And then we have divisibility by 8. This is if the last 3 digits form a number divisible by 8. So let's look at letter A, 69,374. Can 74 be divisible by 4? No. Okay, let's look at letter B. Can 36 be divisible by 4? Yes, it can. 4 times 6. 4 times 9. Okay, let's look at letter C. The last 2 digits for number 4, divisible by 4. Can 4 go into 84? Yes, it can. Okay, now let's focus on divisibility by 8. We're focusing on the last 3 digits. Can it be divisible by 8? Okay, 374. So we can divide. So instead of dividing the whole thing, we can just do the last 3 digits, 374. 8 going into that? No, it's not divisible. Okay, let's look at the last 3 digits, 436. Can 8 go into that? No, it cannot. Let's look at the last one, 984. Can 8 go into that? Yes, it can.